Identify how gears are meshed. The gears in the John Deere power shift transmission are in constant mesh. This means that the gears in the clutch arrangement are always in physical contact and rotating together, but they are not necessarily engaged to transmit power. Some of the major components for a planetary transmission are the input shaft, which connects the transmission to the engine and transfers power to the transmission systems. Some other major components is the interaxle differentials. This component allows torque to be distributed between the front and rear axle, also allowing them to turn at different speeds. The clutch arrangement is used to engage and disengage differential gears hydraulically, enabling torque to be transferred to the drive axle. Lastly, the transmission control valve routes hydraulic fluid to control the engagement and disengagement of the clutch.
How does the transmission engage different gear ratios? John Deere's PowerShift transmission uses multi-plate wet clutch packs controlled by an electric hydraulic control valve using solenoids to apply pressure to squeeze clutch discs together. These solenoids function by passing electric current through a coil of wire, creating an electromagnetic field that pushes a movable magnetic plunger inside the coil. This linear motion is used to lock the previously freewheeling clutch to the drive shaft, allowing torque to be transferred and desired gear ratios to be achieved.
Explain the use of the interaxial differential. The use of the interaxial differential is crucial for management of power distribution between the front and the rear drive axles, and maintaining traction and stability while the truck operates on off-road terrain. In normal condition with good traction, the differential allows the axles to rotate independently from each other, which prevents tire damage and stress on the axle components. So what this means is we got our sun gear, ring gear, and planetary gear. If there's no resistance at the axles, then the planetary gear will stay still, since the gear rotation is going to be 1-to-1 ratio, which is like as if the machine is moving on a straight line. But when one wheel slows down or one axle slows down, for example, if the machine, one side is on the snow and then the other side is on asphalt, then the planetary gear would turn to balance the axle's output. So if one side takes an extra 2% of force, it would make up for it by subtracting 2% from the other side. So the goal for the planetary gear is always to match it to 1-to-1 ratio, and the gear will turn on the shaft until it's balanced.
Question 5. Show the power flow for first gear forward. The power flow required for first gear forward starts from the engine, which sends power to the input shaft. From there is transferred to clutch V that drives clutch A, which when clutch A is engaged, it locks to clutch C, which drives clutch F, which is the planetary high-low. By locking or releasing different parts of the planetary gear set, the transmission creates two distinct speed ranges. In this case, since first gear is selected, low range or gear reduction is required. Power can now be sent back through clutch F through the interaxle differential and to the wheels.